All right, let's jump straight into this explainer. Today, we're going to explore how the invention of the clock didn't just give us a way to measure our days, but actually fundamentally rewired human history. We're looking at one of the oldest human inventions ever, and we'll see how our deep desire to slice the day into smaller and smaller pieces ended up changing not just our technology, but our very psychology. So here's the real million-dollar question we're going to unravel. When exactly did our ancestors shift from just observing natural units of time to obeying rigid artificial schedules? Because, for most of human history, time was simply the sun moving across the sky or the changing of the seasons. But today it's a glowing number on a screen that dictates exactly where we need to be and when. So how on earth did we get here?
Section 1, Measuring Sun and Water. Ancient history and the need to track natural units. To really understand our modern obsession with schedules, we have to look way back, long before gears and batteries were even a thought. Ancient civilizations figured out early on that they could use continuous flowing natural processes, like the position of the sun or water dripping or sand falling, to mark the passage of time. Take a sundial, for instance. It literally just shows the time by displaying where a shadow falls on a flat surface. And water clocks, alongside those sundials, are possibly the oldest time-measuring tools we know of. But here's the thing. They completely relied on a continuous, steady flow of nature to estimate how much time had passed. Now check out some of these early milestones. What's absolutely fascinating here is that despite some seriously incredible engineering feats, like Susong's massive 30-foot astronomical clock tower built in 11th century China, these devices were still entirely a slave to nature. That tower was an unbelievable hydromechanical structure, sure, but it depended completely on liquid flow. In fact, to keep the whole thing running during freezing winter temperatures, they actually had to substitute the water with liquid mercury. I mean, wow. Section 2. The Monks' Mechanical Revolution. The invention of the mechanical clock and the shift to schedules. Okay, so the major plot twist in our story happens in Europe, and it was driven by a surprisingly specific human need: prayer. Frustrated by those unpredictable natural elements, like water freezing over in the dead of winter, monks decided to develop the first fully mechanical clocks. Why? To strictly govern their daily routines. In European monasteries, ringing bells at the exact canonical hours for prayer was absolutely crucial. Water clocks just weren't cutting it. So right around 1275 to 1300 AD, weight-driven mechanical clocks made their debut. And, fun fact, the very word clock actually comes from the medieval Latin word cloca, which literally means bell, simply because these early machines were built primarily just to sound the bells for prayer. And this is where the idea spreads like wildfire. It brilliantly illustrates how a tool designed specifically for monastery schedules cascaded outward in just 2 centuries to control the lives of everyday people. Within 200 years, clock-based timekeeping left the abbey and popped up in towns and city squares across Europe. Suddenly, it wasn't just monks living by the bell anymore, it was merchants, tradesmen, and eventually the entire workforce clocking in. Section 3. How every clock works. The universal anatomy: power, oscillator, controller, counter, indicator. So whether we're talking about a rusty medieval tower clock or that sleek digital watch on your wrist, let's peel back the layers. Under the hood, the underlying logic is exactly the same. Every modern clock uses these 5 exact steps to convert raw power into a readable display of time. You start with a power source. Maybe that's a heavyweight falling, a wound-up spring, or just a modern battery. Next, you have an oscillator that repeats a motion over and over. Then a controller, like an escapement mechanism, keeps that motion going and turns it into crisp, measurable pulses. After that, a counter chain, usually a bunch of gears, adds up those pulses into seconds, minutes, and hours. And finally, the indicator. That's the hands on a dial or the digits on a screen that actually show us the result. Now, of all those parts, the absolute game changer is this one physical object: the oscillator. This is what replaced that continuous, messy flow of water with a precise, repeating beat. It's the literal heartbeat of modern timekeeping. Whether it's a swinging pendulum, a pulsating quartz crystal, or vibrating electrons, a harmonic oscillator naturally wants to vibrate at one very specific, stubborn frequency. And that, right there, is what allowed clocks to become astonishingly accurate. Section 4. The Quest for Precision. Navigation, Pendulums, and the Chronometer. So, once we nailed down the basic mechanics, the high-stakes world of global sea navigation kicked off a frantic race for ultimate precision. Looking at this timeline, you can see how we went from crude, early escapements all the way to mind-bending quantum atomic measurements. In 1656, Christian Huygens hooked a pendulum up to a clock, which was a huge leap in accuracy. But, well, pendulums are completely useless in a rocking ship out at sea, and navigators desperately needed to know the exact time back home so they could calculate their longitude and actually figure out where they were on the globe. This single massive problem drove the greatest minds of the era crazy.
To solve this longitude nightmare, a guy named John Harrison built a marine chronometer in 1761. And get this, it lost less than 5 seconds over 10 whole weeks at sea. That is a monumental achievement. Harrison practically spent his entire life perfecting this thing, coming up with brilliant tweaks like combining different metals so the clock's parts wouldn't expand and jam up in the tropical heat. Being off by just 5 seconds after 2.5 months meant a ship could finally reliably pinpoint its exact location on the open ocean. Just incredible.
Section 5. The Atomic Age. Quartz, Atomic Transitions, and Ultimate Accuracy. Moving into the modern era, those physical, clunky gears eventually gave way to the invisible, high-speed vibrations of the microworld. While quartz crystals totally revolutionized everyday consumer watches, it's actually the vibration of cesium-133 atoms that serves as the formal definition of a second today. In a quartz clock, a crystal vibrates when you shoot a little electricity through it. Super cheap, highly accurate. But an atomic clock? It uses a laser to measure the transition of energy levels inside atoms. This is so insanely precise that a modern atomic clock wouldn't lose a single second even if you left it running for trillions of years. Literally trillions. Without that level of pinpoint precision, the GPS networks our entire modern world relies on simply wouldn't work. Section 6. Shift in Human Consciousness. The philosophical and cultural impact of timekeeping.
All right, but here is the absolute most important takeaway from this entire explainer. We need to look at how this technological quest fundamentally altered our psychology. We shifted from a natural, fluid existence anchored in the present moment to a highly regimented life where we're just constantly anticipating the future. Before the clock, humans were task-oriented. You just did what the moment required, right? Harvesting when the crops were ready, sleeping when it got dark. But as mechanical timekeeping spread, time itself became an abstract concept. We actually started visualizing our days as empty boxes of time that we had to fill up. We stopped responding to the world right in front of us and started obeying the ticking schedule on the wall.
So it really begs the question. It's an incredible irony, isn't it? The very monks who invented the mechanical clock to rigidly track their schedules are now the same ones most focused on mindfulness and returning to the present moment. We built these amazing machines to master our days, but you have to wonder if we've accidentally allowed them to master us instead. So, next time you check your watch or glance down at your phone, ask yourself, are you just passing through another box of time, or are you actually living in the moment? It's definitely something to think about. Thanks for exploring this amazing journey with me.